Hello everyone, Patrick Clayton here with a discussion video question. In this question, we are tasked with solving the equation 3x divided by 3x minus 1 plus 1 over x equals 1 over 3x minus 1. So before we start solving this, it's important to notice that here we have variables in our denominator. Whenever we have variables in the denominator, that means there's the potential for us to set up a situation where with certain values of x plugged in, we could be attempting to divide by 0. Since that is undefined mathematically, we can't let that happen. So there's certain restrictions on solutions to this problem that we should note before we go further. So anytime we have a variable in a denominator, we should take that expression and say that that cannot equal 0 and solve for the case of x in that case. So here I'm going to add 1 to both sides, which gives me 3x cannot equal 1. Then I'm going to divide that 3 so that I'm isolating x, and that gives me the restriction that x cannot equal 1/3. Here, this one will give me the same solution since it's the same expression. And here I have just an x in the denominator by itself, which also, if I set that not equal to 0, means x cannot equal 0 as well. So our restrictions on our solutions for this problem are that x cannot equal 1/3 and x cannot equal 0. So we need to keep that in mind as we go through. When we get solution or solutions to x, that if any of them are one of these particular solutions, that is not a valid solution to this problem. So moving on with the problem, the first thing I'm going to want to do here is get rid of these fractions. There's other ways you could go. You could, try to get a common denominator and add, but I'm just going to multiply this whole equation by a common denominator of all three of these denominators. So 3x minus 1 already matches. X does not. So basically, the thing that these have in common is just going to be x times 3x minus 1 would be a common denominator, so I'm going to multiply the entire equation by that and distribute it. So for the first term, I'm just going to write this out. I don't usually include the whole thing, but for the purpose of demonstration, I will, in this case, show what happens when we do this. So it may take me a minute to write this here. And then 1 over x, and that equals x times 3x minus 1 times 1 over 3x minus 1. So essentially, this 3x minus 1 in the numerator here, we can think of these as all being over 1 if that's helpful to you. But yeah, this being in the numerator and this being in the denominator can be canceled. Same here with the x, 1 in the numerator, 1 in the denominator, and in this last term, the 3x minus 1 again. So when we have basically the part of the common denominator we came up with that isn't the denominator is what we're going to multiply by the numerator. So usually I'd just skip this step and go straight to that, but I wanted to show you guys just so you can see how that works out. So 3x times x gives us 3x squared. Here we just have a 1 by 3x minus 1, which is still just 3x minus 1. And on this side, we have 1 times x, which is just x. So I'm going to subtract x from both sides to set this up as a quadratic equation equal to 0. And when I do that, I get 3x squared plus 2x minus 1 equals 0. And now I'm just going to factor this quadratic. Again, 3x squared only has one real factor set. That's 3x and x. My second sign here is negative, which means I have both a positive and negative sign. I don't know which one's which yet because that 3, it'll make a difference which one's where. But the factors of 1 are just 1 and 1. So I can fill those in immediately. Now I just got to figure out the signs. I need the difference to be 2, which means I need the 3x term to be positive, and that's the outside pair, so the positive sign goes there. Negative sign goes here. That is going to be equal to 0. Now I'm going to use zero factor property, set both of these factors individually equal to 0 to solve for my potential solutions. Remembering that there are restrictions in this case that I've denoted up here. So that's why I say potential solutions. So for this one, I'm subtracting 1 from both sides. Gives me x equals -1. I double check this solution against my restrictions, which are 0 and 1/3, and -1 is not on that list, so that is a valid solution. And when I go to the other one, I'm adding 1 to both sides to get 3x equals 1. Then since 3 is being multiplied by x, I'm going to divide both sides by 3. And that gets me x equals 1/3 as the other potential solution. But again, if we go back and check our restrictions, x cannot equal 1/3 because it would give us a divide by 0 in both of these terms. So that potential solution needs to be rejected, and this is a big hang-up for students why they get these problems wrong, is they forget to do the restrictions, or they do them and then forget to apply them once they've got the potential solution that is restricted. So don't forget to do that. And if you'd like to do one of these problems for your video discussion, the problem I'm giving you is solve 6 over x minus 1 plus 7 over x plus 2 equals -15 over x squared plus x minus 2. Thanks for listening, and have a great rest of your day.